We briefly recalled the quadratic formula in a prior video. Now what I'm going to do is I'm going to go through it a little bit more thoroughly. So the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And there's different parts to the quadratic formula. A part that's of utmost importance is called the discriminant. The discriminant provides us information that tells us the types of solutions we're going to have. If b squared minus 4ac, if the value underneath the radical is positive, if we're going to have to erase that. If b squared minus 4ac is positive, if it's greater than 0, then we're going to have two real solutions. And if I try and undo that, it's going to undo a whole bunch of typing. Then two real solutions. If, I'm betting 1,000 here, aren't I? If b squared minus 4ac is less than 0, if it's negative, then we have two complex solutions. And the reason they'd be complex is because you would have a negative number underneath the radical, and the square root of a negative number is going to be an imaginary number. So positive, negative, well, what happens if b squared minus 4ac equals 0? Then we will have one real, unique solution. One real unique solution means that we're going to have a multiplicity. That solution is going to occur twice. So let's try that out here. We're going to solve this equation, 2 over x minus 3 minus 4 over x plus 3 equals 1 using the quadratic formula. Well, you might say, how is this a quadratic equation? Because it's not quadratic, it's a rational equation. Well, when we have this equation, we clear the fraction. So remember, when we clear that fraction, we're going to multiply every term in the equation, which there are 3 of them. We're multiplying every term by x minus 3, x plus 3. So x minus 3, x plus 3. And that goes for the constant on the right-hand side as well. The x minus 3's cancel, and we have 2 times the quantity x plus 3. The x plus 3's cancel, and we have negative 4 times the quantity x minus 3. And here we have 1 times x minus 3 times x plus 3, which is x squared minus 9. I'm going to distribute. I have negative 2x plus 6 on the right-hand side of the equation equals x squared minus 9. We're going to add 2x to both sides. Six equals x squared plus 2x minus 9. We're going to subtract 6 from both sides. So we're trying to get this into standard form. because our best way to solve, if it's possible, our best way to solve is by factoring. So I'm going to try to factor this trinomial, and it does indeed factor x plus 5, x minus 3, and then we set each variable factor equal to 0 and solve, giving us x equals -5 and x equals +3. And that is our conclusion of solving with the quadratic formula, which I didn't solve with the quadratic formula. So some of you might have noticed that it was much easier to solve by factoring. And if it's much easier to solve by factoring, by all means do it, unless it tells you using the quadratic formula. So this really is a great example to show you solving by the quadratic formula. A equals 1, B equals 2, C equals -15. X equals the opposite of B, plus or minus the square root of B squared minus 4AC all over 2 times 1. X equals -2 plus or minus 4 plus 60, which is 64. 64 is indeed a perfect square. So we're going to have x equals -2 plus 8 all over 2 and -2 minus 8 all over 2. So that's 6 over 2, which is 3. And the other one is -10 over 2, which is -5. So x equals 3 and -5. And now that concludes our lesson for the quadratic formula, seeing that it's not always the most efficient way. So in purple, I just love when that happens. I gotta fix that button. In purple, more work. It's effective, but definitely not efficient. The easier way is definitely factoring in this case. So when you can factor, I do.